Welcome to Searching Algorithms. In this lecture, first of all, we'll understand what a searching algorithm does, or what searching algorithms tend to do, and then we'll look at two different examples of searching algorithms. The first we'll be looking at is linear search, and the second we'll be looking at is binary search. So let's start off by understanding what searching algorithms are. And as we've gone over earlier, an algorithm is a process or set of rules to be followed in calculations or other problem-solving operations. So basically a set of directions or instructors or anything in order to calculate or determine something. And the purpose of searching algorithms is to find a key in a list of n elements. And basically what I mean by a key is, let's say that we have a list of different numbers, 1, 5, 7, 6, 3, 1. So let's say I want to find the 7 in that. I want to find the location of 7, or I want to find out if this 7 is even present in a list. So that's where you would use searching algorithms. So we're kind of going to use searching algorithms to find out what are the most efficient ways of finding something inside of a list, because when you have big lists, it's important to be able to find things quickly, otherwise that's going to slow down your programs. So we're going to look at linear and binary search to see how that works. So first of all, let's look at linear search. And linear search is often also called sequential search. So either name goes, both refer to the same concept. And it's a very simple algorithm. It basically starts at the first element, and what it does is it goes through a list, first element of a list, it goes through that list element by element until a key is successfully found. So until the number that they're looking for is successfully found, it'll keep going by element. So the 0th element, the first element, the second element, the third element, and so on. So it's really basic, how you would expect when you're looking through a pile of books. You'll look at each book one by one in order until you find the book that you need. And if it finds the key that you need, it'll return the index of that key. So for example, if you're looking through a list 1, 2, 3, 4, 5, and you want to find whether there's a 2, or you want to find the index of the element 2 if it's present, and you're using a linear search algorithm, the linear search algorithm will go through this list which has 1, 2, 3, 4, and 5. And the moment it goes element by element, so the moment it comes across 2, it'll automatically just get the location of 2, or its index, and its index is 1 because it's the second element in the list, and it'll simply return that. And if -1, it will be returned if whatever element or key you're searching for is not present in the list. So now the best case, or like the most efficient case, or the requiring the least work, would be when the key is the first element, and the worst case would be when the key is the last element or it's not present, because in the worst case the computer's going to have to go through every single element, which is really a lot of work. And on average there are n divided by 2 comparisons. So that means that on average the computer will look at n divided by 2 elements, or compare n divided by 2 elements, and n represents the number of elements in a list. So now let's look at binary search, which is a little bit more complicated but still relatively simple. Now, one big catch, a very important catch about binary search is it's only used for sorted arrays or sorted lists, which means that we've looked at sorting algorithms, so the list or array, whatever you're looking at, must be in ascending order in order for binary search to function. And what it does is it basically uses a technique that we know in the real world as divide and conquer. And what it does is it basically finds the middle of this sorted list, and it determines whether the key you're looking for is less than, equal, or greater than the middle. And it keeps moving whichever way the key is present. So it'll kind of go to the middle. It'll say, is the key to the right or is the key to the left? And if it's to the left, you'll go to the left side and find the middle of the left side, and so on and so forth. And it'll repeat that until until whatever specific key is found. So now here's a quick graphic to show you exactly how binary search will work. So now let's say that we have a nice sorted list, and it's 1, 2, 3, 4, 5, 6, 7, 8, 9, anything like that. It's sorted list, any numbers, and let's say that the number we're looking for is 7. So let's say we have 1 through 9, all the digits, and we're looking for the number 7. So now using binary search, what's going to happen is First, the computer is going to determine what is in the middle of this array. What's the middle? And we know that the middle is 5. So now that we know that the middle is 5, the computer is going to say, is 7 greater than 5? Is 7 equal to 5? Or is 7 less than 5? And as we know, 7 is greater than 5. So that means that 7 is to the right of 5, or to the right of the middle. So what happens now is suddenly this entirely black array becomes half black and half white. And the reason it becomes half white is that white side represents the side that cannot contain the element we are looking for, and the black side represents the side that does contain the element, could potentially contain the element we're looking for. Now what we've done is we know that this element, and now we know that everything to the right of the middle, which is 5, is where our element is present, and we know that our element is our element is 7. So now the remaining numbers we have left are 6, 7, 8, and 9. Now 6, 7, 8, and 9 are left. So now what the computer does is the computer finds the middle, which is 7.5, and it says, is 7 less than 7.5, or is 7 greater than 7.5? And we know that 7 is less than 7.5. So now within this half of the list that we have, we find out that the element we're looking for is in the left half of this half of our list. So basically now what happens is that existing that half that we have already is now split into half again, and the left side remains the area where we can find our element, and the right side is white now because we know that our element is located to the left of the middle. And similarly, we continue this process until we eventually come to 7. So basically what happens is we get a list. We start off with a huge list which has all of our numbers. We find the middle, and we find out whether our element is to the right, left, or is exactly the element in the middle. And then after we find that, we concentrate on the half that contains our element, and we do the same thing. We split it in half and find which side contains our element and focus on that side. And that's what really speeds up this process. But remember, in order for this to happen, the array has to be sorted. Otherwise, the computer cannot find out or the algorithm cannot find out if something is to the left or the right of an element. So now the best case that could possibly occur was that the key is exactly in the middle. And by that I mean that exactly in the middle. So the first time this algorithm runs, automatically when it checks the middle, it will find the key. And the worst case is that it's not in the list, or it's at the end of a sublist. That means it'll require the computer to do a maximum amount of splitting in half in order to find the key. So now let's move to Dr. Java and see how these searching algorithms exactly will be implemented. So here we are in Dr. Java. I have a class open, and this class is called the search test class, and we have two methods in this class. We have the linear search method and we have the binary search method. So let's first walk through these methods and understand exactly what goes on, and then after that we'll run this program and see what happens then. So here we are at the linear search method, and with the linear search method it returns an integer. We've kept this method static so that we can run it within this class, and it takes in two parameters, an integer array and an integer key, and a key that represents it is an integer. And remember, as you remember, linear search or sequential search, as many refer to it as, it goes element by element and determines whether it's the key. So in this case, what happens is whatever this array is, the variable size is set to the value of whatever this array is. So array.length, remember, gives you how many elements are in an array, and it says size is equal to how many ever elements are in this array. And after that, it runs a for loop. So for int I equals 0, I is less than size I plus plus. So basically I starts at 0, and we make sure that I is less than whatever the size of this this array is. And if I is basically used to represent the index. So if we say that the ith element, whatever I is, like let's say 0, so array 0 equals key, it'll return I. But if it doesn't, then it's just going to increase the value of I by 1. So with this for loop right over here, what's happening is basically I is getting a value of 0, And then we're saying that if the 0th element in the array is equal to the key, then we return 0 because that's the index. But let's say that the 0th element is not equal to the key. Then the computer increases the value of I by 1, and suddenly the value of I is now the value of I is now 1. So now it looks at the first element of this specific array and checks if it's the key. And if it's not, it'll increase the value of I again, and so on and so forth until it reaches the size when the for loop stops iterating because of this condition. And once the for loop stops iterating, then that's it. Basically, the element was not found. And if this for loop stops iterating, then -1 is returned. But the moment something is returned, the method is automatically done running, and I is only returned when we find a match with the key. So this just goes element by element, increasing by 1 every time until it finds the key, and if it doesn't, it returns -1. So really simple. Now let's look at binary search, which is a little bit more complicated, so we're just going to understand it on a high level. So with binary search, what we have is, remember that the array, whatever array we have, it needs to be in ascending order. And after we have whatever array we have in ascending order, we want to say that the lowest element is the 0th element, and the highest element is the array length -1. Because remember, if you were to have an array of 5 elements, then its length would be 5. But remember that it only goes up till the 4th element, because you have the 0th, the 1st, the 2nd, the 3rd, and the 4th element, which make up 5 elements. So the high would be array length -1. Now what's happening is we have a while loop over here. And what happens in this while loop is, while the low is less than or equal to the high, which basically means that whatever our lowest value is, or whatever the lowest element is in our array is less than or equal to whatever the highest index is in our array, we still have more elements to search. So until this evaluates to false, we keep running this while loop, and this only evaluates to false when we finally run out of elements to run, and then low and high, or low is greater than high. So now what we do is, we know that what low is and we know that what high is. So we know that low equals high minus low plus low divided by 2. So what we use this in order to determine what the middle of this array is. And once we find the middle index, what we do is we say if the key or whatever integer we're looking for is less than the the number in the middle, then we're going to say that the high suddenly becomes a lot smaller. And then, so what we're doing now is, before the high was included all of the elements. But now when we find out that the key is on the left side of the array, then what happens is we suddenly make the value of the highest index possible to be 1 less than whatever the middle index is. So now suddenly we're only focusing on the left half. And similarly, if let's say that the key is bigger than the middle of the array, then suddenly the low becomes the middle plus 1, or basically now we're focusing on the right half. And let's say that it's not greater than or it's not less than, then it obviously has to be equal to. So then we return the middle, because that's when the middle is equal to the key. And if none of this turns out to be correct, we'll return -1. So I understand that binary search seems a little bit more complicated, but basically what you need to understand is it splits the array into half and finds out which half the key we're looking for is in, and then it keeps splitting the array like that until it finds the key if it's present. And that's exactly what this while loop is doing. So now what we're going to do is we're going to run two things. The first we're going to run is we're going to have two integer arrays, 5, 6, 8, 2, and 3, and we're going to find out using the linear search method what the index of this 2 element is. So as we know, this is the 0th element, this is the first element, this is the second element, and this is the third element. So as we know, we should get a return of the number 3 over here. And then similarly over here we have a sorted array for the binary search method, and over here what we're going to do is we're going to find where 767 is located. So this is the 0th element, the first element, the second element, the third element, the fourth element, and the fifth element. So we should get a return of a 3 and a 5. So now let's run this and see what happens. So we compile and then we run. And as you can see, we get a 3 and then we get a 5. So those are the indexes of the location of whatever keys we were looking for. And the keys we were looking for are 2 and 767. So now just to recap what we've learned, we've looked at searching algorithms, which we can use to find specific keys or elements in a list. And linear search is when we just go element by element looking for a specific key, and we just keep going element by element like you would naturally. And then with binary search, what we do is we split the array, we keep splitting the array into half and looking at whatever half we know may contain our element. And that's what we can only use when the array is already sorted. But basically what we see now is we've looked at two different ways to search arrays. One is linear search and binary search, and both are algorithms because they are processes by which we can find a specific number in an array, and that's exactly what searching algorithms do.